Good morning, Algebra 2 students. Today we're just going to review solving logarithmic equations and then talk about solving logarithmic inequalities. So if you remember from distance learning on Friday, when we are faced with a single logarithm, the key to doing these problems is going to be to change the form of the problem. So for example, in number 10, changing the form of this, 2 is the base, so it'd be 2 to the fourth would need to equal x plus 3. 2 to the fourth is 16. I could subtract 3 from both sides, and I would get x to be 13. Now, something very important again, especially when we start talking about inequalities, that you can never take the log of a negative number. So we got to make sure we check this, and if we plug 13 in for x, this value needs to be positive, which it would be. So in number 12, we change the form of that. It would be 8 squared is equal to 4x plus 4. 8 squared is 64. And then solving, I would subtract 4 from both sides, divide by 4, and I would get x to be 15. And again, plugging that back in will also make sure I'm taking the log of a positive number again. The other step or process we use, if there's multiple logs and if the bases are the same, so for example, in this situation, they're both base 3. So for these to be equal, x minus 5 would need to equal 13. So I just set them equal. I would add 5 to both sides and get x to be 18. Plugging that in and checking, I'm not taking the log of a negative, and it is true. Number 18, you can see our bases are the same. We have multiple logs. I'm going to set these equal. And by solving, I could subtract x. And I would get x to be negative 3. Now, if you check this and you plug negative 3 in for x, you can see here that you'd be taking the log base 6 of a negative 6, which you cannot do. And so therefore, this is not a solution. And in this case, there would be no solutions to this equation. Now, in working inequalities, kind of the same type of thing. We're going to change the form, but we got to make sure we're never taking the log of a negative number. In number 1, we're going to change the form of this, but we're going to start with this 2x. So as far as 2x, that would need to be greater than the base, which is 2 squared. And so 2x would have to be greater than 4. If I divide by 2, x would have to be greater than 2. Now, very obvious, if x is greater than 2, this would never be negative, and so that is my answer there. X is greater than 2. In number 2, the 3x plus 1 will need to be less than 2 to the fourth power. So 3x plus 1 would have to be less than 16. All right, I also know that 3x plus 1 cannot be negative, so it has to be greater than 0. So I form a compound inequality. If I solve this, I would subtract 1 from all 3 parts. I would divide by 3. And my answer would be between negative 1/3 and 15/3. So that's an example of a less than, where you got to make sure you're not taking the log of a negative number. In number 3, we'd have x plus 3 would have to be less than 3 cubed, which is 27. And again, this has to be greater than 0. If I subtract 3 from all 3 parts, I'd have negative 3 is less than x is less than 24. And that would be my answer there. Same type of problem if you have multiple logs and you have an inequality. You have base 10. So then the 5x has to be less than 30. And therefore, dividing this, x would have to be less than, or actually the 5x would have to be greater than 0 again. Can't be negative. So then I would divide everything by 5, and I would have that x has to be greater than 0 and less than 6 for this to be true. For number 9, 3x would have to be less than 7x minus 8. In this case, I could try to solve for x here. If I subtract 7x from both sides, I'd have negative 4x is less than a negative 8. If I divide by a negative 4, remember that reverses the sign, so x would have to be greater than a positive 2. And if it's greater than 2, it does not make either the 3x or the 7x minus 8 negative, and so that would be my answer. Number 12, and this is from the 8.4 practice there, the 3x minus 4 would have to be less than the 2x plus 7. If I would subtract 2x from both sides, I would get x. If I add 4, I would get 11. And so therefore, x would have to be less than 11. But in this particular case, it can't be negative, so we've got to make sure that the 3x minus 4 has to be greater than 0. And if that's the case, x would have to be greater than 4/3. And then also the 2x plus 7 would have to be greater than 0. And in that case, x would have to be subtracting 7 and dividing by 2. X would have to be greater than a negative 7/2. All right, so we're looking for the lower end of this, and to make them both positive or both greater than 0, the x would have to be greater than 4/3. So I could add this to the lower extreme of that problem, and this would be my answer. So I hope that helps you in solving some inequalities with logarithms. For your assignment here in the 8.4 practice, I want you to do 1 through 6 all, and then 7 through 17 the odds, which would be the inequalities.